Good morning. Hey, all right. Hey, thank you so much. Good morning, everyone. Welcome to day 2, depending on how you count it, depending on when you got in, of DevOps. And it's really, really good to be back. I think we all can agree on that, I hope. So thanks for inviting me back. I'm going to launch right into this, and we'll kind of go as things develop. No pun intended. This will be filled with my sparkling sense of humor. Those of you who don't know me, yeah, somebody laughed, so you obviously don't know me. I'm just kidding. But hey, I was actually in the hallway. Those of you who know me know that I came from the Spring team. I was a longtime Pivotal Spring advocate, and then VMware Spring advocate, and then I came to Microsoft about a year and a half ago now. Gosh, it doesn't seem like it's that long. But interestingly, I was chatting with a former colleague of mine, still on the Spring side, and he showed me this. This is the T-shirt that they brought. And there was no coordination whatsoever. So I don't know whether I cribbed off them, they cribbed off me, or if it was just kind of like, the minds went in the same direction. But the whole build better, deploy faster apparently is a thing. So, hey, welcome to 2022, right? Welcome to this morning's deep dive on Build Better, Deploy Faster. That wasn't nearly a long enough title for a Spring talk, so I added on to it. Wow, new to Spring, huh? Okay, all right, anyway. So I added on to it, Spring Boot and Spring Cloud in the cloud for frictionless Kubernetes-based microservices. My name is Mark Heckler. I'm a principal cloud advocate of Java and JVM languages. Now with Microsoft, again, you know my history. I came from Pivotal and VMware. And I still work on a lot of the same things with a lot of the same folks. I just do it from another location and another, quote, building, so to speak. But we're all good friends. We all work together. We all want to make sure your apps get to production the best way possible. Which is kind of one of the reasons I went to Microsoft. If some of you have memory like I do, you probably remember a time when Microsoft wasn't always envisioned as the best citizen in the community, but those times have changed. We've ceded the curmudgeon title to others in the industry, and I won't mention names, but you probably can figure that out. So anyway, if you have questions, comments, or feedback, I will be stopping at different times and ping me then, if you will. I hate to interrupt a flow when I get a flow going, but please, jot a note, ping me afterward, in the breaks, or if you think of them afterward. This always happens to me. 10 minutes after I walk out of a session, that's when I think of my best questions. That's when I think of the thing that I really wanted to ask or wanted to say or whatever. That's fine. Again, happens to me too. So reach out to me via email if you must, or better yet, on Twitter. I check email, occasionally. I gave you my 2 email addresses that I check the least infrequently. Least infrequently? Wow, this is a tough room. You really didn't have your coffee. But I live on Twitter. Those of you who follow me on Twitter know that. If you don't follow me on Twitter, the only question I have for you is why? Why don't you follow me on Twitter? Twitter is the best way to reach people. It really is. I find it's a great way to just dash off a quick note. If you have questions, comments, or feedback you don't want to share with the entire planet, anybody who happens to be scrolling by on Twitter, my DMs are open. So just follow me, shoot me a DM, and I'll see it, and we'll start the conversation there. Perfectly fine. And of course, around here in the hallways, that's good too. I am going to be in a hands-on lab working with a couple of colleagues of mine, 3 colleagues of mine this afternoon. So if you're interested in that, check it out as well. But other than that, I'll be available, and Thursday I have a session. But other than that, I'll be available in the hallway to talk. So a bit about me. I am an architect and developer. By background, I obviously am an advocate. I always tell people advocacy is kind of an accidental profession because most of the time it happens when you're a developer and you share something and then somebody says, share it here, do a brown bag lunch thing, come speak at a Java user group. Next thing you know, you're in conferences. But it combines the 2 things I love to do most in life, which are code and talk. So it's a great profession if you like to code and talk. I am an author, and I'll get into that a bit more later. A Java champion, Java 1 rockstar, Groundbreaker ambassador, Kotlin developer expert. I like to code. I like to get out there again. So it kind of makes sense. I am also a licensed instrument-rated pilot. I find that who here has ever thought about flying? Yeah, I think there's a great crossover, and interestingly enough, I think there's an even bigger crossover between developers and anybody really in the tech field and instrument-rated pilots, because when you are instrument-rated, when you're VFR, Visual Flight Rules pilot, you get used to looking out and watching the horizon, and of course looking for traffic in Visual Flight Rules conditions, VMC, they're called Visual Meteorological Conditions. But when you have to learn for an instrument rating, you have to take your gaze back inside, because many times it's just clouds. You can't see anything, and you have to trust the instruments. That's what we do every day, right? We trust the computer. We get used to assessing the data that we're seeing if it makes sense, and relying upon that for many, many very critical, sometimes life-critical decisions. And that's exactly what that is. So if you've ever thought about it, I encourage you to do it. It's a lot of fun, and it helps you to see the world from literally a different perspective, several thousand feet up. By the way, I am from the US, so we use measurements that are strictly based in rationality and logic, like feet, because that makes a lot of sense. Interestingly, though, aviation is this weird melange of terms and measurements. I mean, we have temperature in Celsius. We have barometric pressure in inches of mercury. We do statute miles. We do nautical miles. We do all kinds of crazy stuff mixed in. We have terms that are French. For mist, it's brouillard, I think. Pardon my French. It's literally, pardon my French, it's terrible, I know. But you have a lot of things that are kind of mixed in. So it's a very weird discipline, but it's kind of fun too. So anyway, enough about that. So I had contributed content and code to several books. I co-authored a couple of books with dear friends of mine, colleagues I respect and just love to spend time with. And I realized very quickly that even though it was a lot of fun, it was a lot, and I mean a lot of work, an inordinate amount of work. So I swore that I would never, ever, ever write a book solo. And then the pandemic hit, and I'm like, hey, why not write a book? So I did. I'd actually been taking notes on this for a long time on things that, because every author has a different perspective, things that are very important for them, they feel like more important to cover, and things less. Sometimes it's the way things are covered. So I'd been taking notes for a long time, but when the pandemic hit, I felt like it was time to go ahead and make it happen, so I did. If you're interested in knowing more about it, follow the link, the bit.ly link, or just follow the book on Twitter, because the book also has a Twitter account. And you can get a 7-day free trial, I think, if you want to check out via O'Reilly. So this is a deep dive, right? So this is deep. This is in the depths of the ocean. No light can penetrate it. We only have 3 hours, though. They would not give me more than that. So this will be more like this. We're going to cover things. We'll go to some depth. We'll go to some breadth. We'll cover some things, hopefully, that even if you're familiar with the domain, you may not have thought about this way or heard or maybe just explored that particular weird edge case. So we will be diving into it, but it won't be quite like that. Well, more like this, and that's good. So what's on the agenda? I like to set context because early on I started diving right into code, which is a lot of fun, but I got a lot of the same questions afterward on how does this fit here? What is this? How does it make sense? And I thought, a little context always helps. All right, okay. So I start with a little bit of context because I think that's important to see where all of the pieces fit, right? And then we launch into the code because that's kind of where we live. I often think of the whole context and code in terms of Google Maps. Anybody use Google Maps, Apple Maps, any of it? Yeah, I mean, come on. You have to get around. Anybody who's not from Antwerp, right? So you used Google Maps this morning probably to make sure you got to the right place at the right time. I know I did. Because it's been 3 years, and sometimes you remember things very precisely, and then sometimes you remember things that aren't there, and you're thinking, where did that come from? So Google Maps. So you plug in a destination, and what happens once you do that? It pops up a map, and that's your context. But when you really want to get into the details, what do? You hit the turn-by-turn directions, and that's where you see follow this number of stops on the metro, or take this turn at this street and that turn at that street and all that. So I think it's important to have both. The context first, and then we dive into the code, which are kind of the turn-by-turn directions. And then we'll go clouding. Pardon the verbification, I guess, of that word. But I think it's this is where we get into the payoff, right? And I'll get into why I came up with this talk very shortly, like next slide. But that's kind of the order of the day. the order of the morning. And we'll take the occasional break because I am not a monster, right? I'm not going to try to make you sit here for 3 hours. I can't do that because I have my coffee, right? So I encourage you to drink plenty of coffee, and then that necessitates a break once in a while anyway. So Spring Cloud, this is the start, right? This is the context. And I need to go back just a little bit because most of us have worked, are working, or will work on a monolith. Monoliths are not a bad thing necessarily. They're an architectural choice, and every choice that we make, architecturally or otherwise, has trade-offs. We have pros, we have cons. Every architectural choice has numerous options or numerous examples of both, pros and cons. I'm going to focus on one particular con with monoliths because I think it kind of outweighs all the others. Outweighs the other. Oh, gosh. All right, drink them if you got them. Man, I'm going to have to really trot out the great humor because the good humor isn't getting it. Okay, so a monolith, when you need to scale, a monolith almost by definition includes multiple capabilities. Do you mind if can I walk out here like this, or will that throw off the video too much? Okay, I like to move when I can, and then when I get coding, I'm anchored. So when you have a monolith, it incorporates multiple capabilities, what I call capabilities. You can call them whatever, functionality, etc. So let's use an example of a retail application, but we don't want to step on anybody's toes or infringe anybody's trademarks or anything. So I'm going to call it something that doesn't resemble anything at all, no correlation to anything in the real world. We'll say that this is called the Amazon, right? Or Malwart, or Aliboo, or whatever you want to call it. We have an online retailer, and we are deploying this as a monolith. Questionable choice to be sure, but let's say we are going to do that. So it has multiple capabilities within this monolithic application that's going to service our retail application. So it may have a catalog, and you look up something and it has maybe prices from different vendors that are authorized to sell through your storefront. So you may have your own in the Amazon, let's say, we'll use that as our example, and you may be able to fulfill those product orders through your own stock, or you may have other third parties who will list theirs for sale as well, the same thing. So you have a catalog, and then you have once somebody puts that in their cart, you have a cart service. You have, once they decide to order, you have to check their payment methods and make sure that they are legitimate, that they have that much credit available, etc. You have to process the order to ship it. You may have to do a reorder if it's coming out of your stock, etc., and so on. Let's say they get it and they say, oh, that's the wrong size. It looks terrible. I don't like it. And they send it, or it's broken. It arrives damaged in shipment. They want to send it back. So there's a returns module, things like that. So all of those capabilities are bundled into this single monolith. So that when you need to scale, what do? You pick up and scale that monolith. Now, I'm not going to be getting into now you're having 2 or 3 or 10 instances of something that may never have been designed to have duplicates. But we'll assume that's okay. What could go wrong? But you're scaling everything. You're picking up stuff that in many cases doesn't need to be brought along for the ride, and you're scaling that as well. I like to think of Black Friday in the US and other places. I think we are the originator of that terrible, terrible tradition. If so, I'm sorry. If not, please tell me so we don't have to take blame for that anymore. But Black Friday shopping, by the way, does anybody know the origin of that term? It's an accounting type of term, right? Yeah, we've got a couple of folks. It's an accounting type of term because when you're positive numbers, like when you're making a profit, everything's in the black ink, right? When you're running in the negative, it's red ink. So typically, there are many ways to look at profitability of a firm. So typically for retailers, in many cases, they would be running at a loss like for the year up until Black Friday sales kick in. And when the Black Friday sales kick in, they go into the black. Now all of a sudden for the year, looking at it for a calendar year, now they're profitable because they sell a ton of stuff on Black Friday. So it's kind of, I guess, cool in that regard. But let's assume that you have a monolithic application for a retail store and you're running that on Black Friday. So a lot of capabilities are really going to get hammered on Black Friday. So your catalog, your product lookup, your ordering, your credit check, your shipping, your fulfillment. But what's one thing that won't be hammered very hard on Black Friday? Probably, in all likelihood. Your returns, right? Those come later. When somebody has buyer's remorse, when they get it and it's the wrong size, broken, etc., or they gift it to somebody, And then after Christmas it comes back, or after whatever holiday it comes back, and they go, ugh, that's got to go back. So the returns, at that point, the return module will be heavily used. But on Black Friday, it's not used really at all. But it comes along for the ride. So at that point, we start looking at how can we scale more efficiently. And that's where things like microservices come in. And I'm not going to debate the size thing, because it's a terrible name that got co-opted by marketing. We all know that. There are so many examples of that in our field. Gosh, that could be a whole talk by itself. But by teasing out certain services, we can scale those as they make sense, right? And scale in the other things, or not scale out, as the case may be, that don't need scaled. So with that comes other challenges, right? Because we're adding a lot of complexity to something that used to be a singular thing. Now we have a lot of things that are having to coordinate and talk and find each other and interoperate, and when this one goes down, maybe spin up another one to take its place. And that requires what I call a kind of scaffolding, and that's where things like Spring Cloud come into being. The Spring team decided very early on that it made sense to have an organized set of constructs that would address this. Now I say the Spring team, but many of these concepts and many of these software packages, if you will, and I'm using that term kind of generically in this case, came from Netflix. Anybody hear of Netflix? No, nobody's heard of Netflix, right? All right. So Netflix is going through some hard times because there are like 1 million streaming services now, but that doesn't change the engineering feats behind what they've done. And in many cases, the Netflix engineers would open source something they were using to drive their business every day, 24/7, 365. And in many cases, they worked with the Spring team to kind of to abstract from them, to make them broader, more applicable in more cases, right? And eventually, what happened is a lot of the Netflix applications, when they were going to be developed, started with the now upstream Spring packages. So you have a lot of capabilities that are baked in to Netflix, deployed software that are actually drawn from upstream. Now, again, as time evolved, the Spring team took on some of these packages, some of these libraries, to maintain them and evolve them to create new Netflix apps. So what are the important things? There are more things than this, but I've chosen a few things to focus on because they're, I feel like, very central to everything else. Configuration. And I've kind of followed the pattern: externalize it, locate it, etc. So configuration allows you to externalize things that are used by numerous instances of a particular application or a particular service. So if you have a service, and we'll go back to our earlier example of an online retailer, so if you have a catalog service and one doesn't do, you need to scale that to 2, 5, 10, 100, whatever. But they have certain properties that are going to be used by all. And what if those properties change, right? So if I think of a property like a database connection string, a URL, a username, password that you might need for a certain service, etc. And if you have that hard-coded in there and something happens, you have to change your code, retest, redeploy, and have to do that at scale. If you externalize those configuration properties, then you can update that and then have a refresh go out so that those can stay running and keep going. You also can do certain things like blue-green deployments very easily when you have your externalized configuration. You also, as having externalized configuration, can set things up for different environments, dev, test, prod, or multiple different production environments, etc. So how do we do that? I will get into that more as we go, of course, live. But Spring Cloud Config Server typically handles that. You can use multiple different things for backends, including JDBC backend, Vault, etc. But most of the time, what folks use is a Git repository, which kind of makes sense because most of these things are properties, right? There's a key and there's a value. They're text. We need to be able to audit them. We need to be able to see when things change, when properties change, and who changed them. And we do that all the time, every day with our code. It's the same idea, right? So I'll be showing you that as we go, but the config server typically handles that load and also allows us, and I will show this as well, where we can encrypt and decrypt properties so we don't have to necessarily pass things in the clear when it's sensitive information. There is a cloud-based option that takes that one step further, which, well, we'll talk about once we get to that point as well. Service discovery, because if you have 10 instances of service A and you have 10 instances of service B, and every instance of service A needs to find other instances of service B, and sometimes those aren't always reliable. They go offline, another one spins up to take its place. You need some way of finding each other. You also need that to be resilient. So Eureka was created. There are other options as well, of course, but Eureka kind of serves as the foundational example. I try to stay with the foundational examples. All of these things that I'm showing you, there are other parallel components you can swap in and out. But I stay with the foundational examples because I think they make the most sense and they provide that broad-based knowledge that applies pretty much across the board. So with the service discovery, you also want that to be resilient where those values are cached. So if anything happens to your service registry, and typically you will have multiple instances of that as well. But even if those all go offline, crazy though it may be, your existing services can continue to run while you bring that back online, or while hopefully your platform does. Then I kind of generally break things out into backend services and consuming services, even though there are some services that do both. But the backend services really kind of crunch the numbers, provide the data, et cetera. The consuming services will offer that up to end users or for other uses. You have a gateway service because typically once you have a massive deployment of numerous instances of numerous microservices, you don't want to have all of them open up to the external world, right? You don't want to have that kind of security nightmare and manageability nightmare. So a gateway service allows you to rate limit, to secure, to route as you choose, etc. And then we'll talk about tracing and load balancing and circuit breaking and reactive flowing and securing and all that as we go. So that's kind of the context. Everybody still good? All right. So let's code. Hopefully it won't go like this, but you just never know. Live coding. Nothing ever goes wrong live coding, right? By the way, you've probably noticed I seal this after I drink it, and like water, the same way. I had a colleague once a few years ago who had a large thing of iced tea sitting up here. And he went through most of his session, got like within 5 minutes of the end. He was home free, and he was animated, and he bumped it, and it went right into the keyboard. Brand new Mac, by the way. It was like 30 days old or less. And it went right in and it went, and he was fast. I mean, lightning reflexes. He grabbed it, threw it up, and of course the tea just pours out. And it went dark, and then it came back, and he's like, because he thought he'd won. And technology does that to us, right? You know, it psychs us out. It's like, ha, yeah, you think you've won, and then it goes, and it is gone. So he got a new Mac, and a lot of grief. But anyway, that's a tale for another day, I guess. So let's get started. Yeah, so here's that. There we go. So we're going to start here with the Spring Initializer. If you're not familiar with the Spring Initializer, that's sad. So this is the way you typically get started building Spring Boot-based services, right? You don't have to go here. You can actually handcraft your own custom, bespoke, artisanal Spring Boot applications. Not a great use of your time. It's very inefficient, but you can. I mean, there's nothing stopping you per se. But the Spring Initializer gets you started fast, right? And it doesn't generate code other than the main application class main method, but it does allow you to choose from the dependencies you want. And I kind of look at those as capabilities as well, because if you came from the old Java-E or Jakarta-E world, you had these massive like pages and pages of dependencies just to do anything, right? So a capability in Spring Boot allows you to bring this up and choose from a bundled set of capabilities, which include all the libraries you need to get that done. They're version synchronized, they're tested together, and it solves a lot of problems and keeps you out of the headache land. You can override any of that, but in most cases you just don't have to, so that's kind of sweet. By the way, if you want to curl this, HTTP this, use it from an IDE, it's the same endpoint. You get the same deliverable chunk that you get down. Your zip file is the same identical thing that's composed the same way. So if you have somebody next to you that likes to hit use curl to hit the endpoint, and you like to use this, it's perfectly good. There are a couple reasons that I really like to use this and go to the actual site. One is this. Yeah, I know it's such a minor thing, but if you spend all your day like this, and then you go to a site and it's just like blinding, it's pretty rough. Can everybody see this, by the way? Okay, so if not, let me know. If anybody can't see something I show, I think I've got all the fonts turned up, but if for whatever reason you can't, just yell it out and I'll fix it. We'll adjust. So we're going to start here. The other thing I like about this, by the way, I'll get to in just a moment, going through the initializer, but this is a good start. I'm going to keep things pretty much down the middle of the road so we can focus on the stuff I want to share versus the window dressing around the edges. So I'm going to use Maven for my build system. if you're a hipster, you can use Gradle. It's all right. I mean, I have my hoodie here too, but I typically stay with Maven when I'm using Java, not when I'm using Kotlin. That's kind of a weird thing, but oh well. 2.7.4, current version of Spring Boot. And by the way, there are going to be some things changing in some of the things I'm sharing with you. And when I think of it, I'll point out what those are, just so you don't get too tied to that particular thing, because like every bit of software, everything's evolving. So I'm going to change this to the hecklers.com because why not? I'm going to create a config service. And I also do in certain cases, make certain choices on what I'm doing and how I do it. And I'll share why. Your mileage may vary, right? Or your kilometerage may vary. But it's up to you. And at least that way you're informed on why I'm doing it this way. And I have made conscious decisions to do it and all that. So I'm going to call this a config service, cleverly enough. And I'm going to use jar packaging because let's see, what year is it? Oh yeah, 2022. Okay, that's good. So jar packaging kind of makes sense, but you can deploy to a war if you're still stuck dealing with an application server. It's not the end of the world. Java 17 because it's the current latest, greatest LTS release, but up to 19 is supported and back through 8. So that's cool. Again, choices. And then config. I'm going to bring in the dependency for config server, right? And it even says central management for configuration via Git, SVN, or HashiCorp Vault. We'll stick with Git today. Now here's another thing that this using the initializer gets you. So if you want to explore it, you can explore the actual structure of the zip file that's coming down, the files and the directories within. Particularly, I like to, I mean, you can go crazy here, but I like to look at the POM and just make sure that my dependencies are where they should be and what they should be, right? And of course, I did select Java 17, etc. One nice thing about this as well, so if you ever need to modernize anything, this is a really good way to sanity check yourself because you can go with the current versions of everything, pull this up, and you can see where you need to evolve. So that's kind of a nice little extra. Okay, so I'm going to generate this, and we'll just drop this here on the desktop. And I'll open this, just unzip it and open it in my favorite IDE, NetBeans. Kidding. Any NetBeans fans here? I like NetBeans. I dish on my friends, right? I don't pick on people I don't like. I don't pick on things I don't like. NetBeans is a great IDE for working with Spring and Spring Boot applications. So I like NetBeans. I like, it's a great IDE. I like IntelliJ. I had used IntelliJ for my daily driver. And I know I know some of you out there are looking going, this is a Microsoft guy on a Mac using IntelliJ to write Java applications. You're probably not going to hear a thing I say after this. Because now that I pointed that out, it's just going to be like bothering you the whole time, But it's true. I mean, we want to help you deploy better software faster. We want to be your target platform of choice. Use what works. So yeah, IntelliJ is great. VS Code, also awesome. I use it all the time. Vim, even VI. Any VI fans? Yes. All right. So don't use Emacs. Please have some self-respect. But Eclipse also is it's an IDE, I don't know. I have good friends I respect who use Eclipse. I just don't, I don't know. I still love them. Anyway, okay, so what I like to do is just open up the POM, again, just a sanity check. I kind of have a routine. We all have routines. I like to pull up the POM, the application.properties, and then my code. And that's just how you'll see that over and over again today. But the only thing we have really here, the only dependency of note, really, is that Spring Cloud config server. And that's by design, right? So I'm going to go and pull up my application properties. If you're not familiar with Spring Boot applications, there are many ways a Spring Boot app can get its environment, its properties from its environment. This is kind of the last resort, right? This is your sensible defaults location, your application.properties within your jar file, within your application file, if you will. This is where I put kind of those sensible defaults, and then if we need to override them, we can do other things as well. If you want to know more about that, come to my talk Thursday. So here we're going to start off just by, since I'm going to be running this locally, I'm going to assign a server port to override the default of 8080. We'll assign this server port 8888, where we want our config service to be running, and then I want to assign a get URI. And you can point this to any Git repository, online, local, whatever. I'm going to point this to my home directory, and we'll just point this to dev session repos because I have this captured. By the way, all the code you're going to see today is online as well, and I'll point you to that as we go. So build better config. And if that's wrong, it'll tell us. That's fine. And then let's go to our application. And let's write a bunch of code. So we're going to enable the config server. And that's it. Now, I want to do this two ways. I'm going to run this from the IDE. And that's all the code you need, because Spring Boot's auto configuration takes over based on your class path. We added the config server dependency, and then a simple annotation. And then, of course, we have to point it to whatever repo we're using for our properties. Now, I'm going to show you, as we go, a few things kind of behind the scenes. And let's see. So we'll go here, localhost, typing accounts. Application local. That's good. All right. Before I do that, I should probably go out and do this. So I'm going to go to this directory. I switch keyboards. I have a travel keyboard I use, and then, of course, the home keyboard. And every time I switch keyboards, I find my finger going to the wrong spot. So apologies. So if we do an ls-l. So this is what I have out there in our repo. Well, actually... So you can see it's a repo. You've got the .get right there, that directory. And then you can see right here, here are the different YAML files. You like YAML, right? Yeah, oh, it's good. Yeah, I saw that cheering, right? That was cheering, yeah. You don't have to use YAML files, but they make a lot of sense. I actually don't mind YAML when it's used as I consider it to be intended, in short, concise areas where you have repeating groups. I mean, that makes sense. It's brilliant for that. When you get into the long pages and pages of YAML where one small indentation error can totally derail everything, not so great. But we're not going to go there today. So here, the Spring Cloud config service can deal with different source files. You have an application file, which is the properties that are served up to everything that requests properties from the config service, right? And then you have certain things that are identified by name, and you can also have like the profiles, so local or different branches if you have different branches in your repo and things like that. But each of these, let's say we have an airport service, and that airport service is going to contact the config server and say, give me my properties. So it will get properties that are applicable to every service, as well as properties that are applicable only to airport services, right? So it gets these things. And there's an order of precedence. The more specific wins. So if you have the same property defined for all apps, and then the same property that's defined for apps of a particular kind, that thing wins, right? So if we look at these, let's see, cat application.yaml, we can see that we've got just some general properties. And these can be specific to, let me rephrase that. These can be system type of properties, so logging level, things like that, metrics information. You can also have things that you define. So I have a couple airplane things, of course, and then I have a token right here. And if you notice, let me zoom in on that, that's encrypted. So I have this with a cipher bracket here. And the Spring Cloud config service allows you to encrypt and decrypt values using the Java cryptography engine, which is not a bad deal. A lot of folks aren't aware of that. But that allows you to encrypt your data at rest, just kind of as a matter of fact, right? You used to be able to do that through the Spring Cloud CLI. That's no longer being maintained, development priorities and all that. But the capability is still there in the config service, and I'll show you very quickly how to do that as well. But I want to get back to this first. So I went just to the application. Just give me the properties for all applications, and just using the local profile, and of course I can change this to anything, default profile. I can change this to mark profile. If it doesn't find a profile for that, it just gives you the general properties. So, and you can see here, and by running this, I actually did not have a mechanism in place, a key in place that allows us to decrypt that. So when it finds something that's encrypted, data at rest, encrypted, and it can't decrypt that, it will just replace that. It'll prepend that with an invalid dot, so you can see something has gone amiss here, and it will give you a not available for your value, right? So we'll get around that here in a moment, but I wanted to show you that that's kind of how that works. And then, of course, if you want to go in and look at a particular application, so airport service, and we'll go to local, and we see that here we've got the property sources listed. The first one is specifically from the airport service.yaml. So these are things that apply just to that airport service, and then here are the things that apply to all services. Once again, we see the invalid AVWX token, the aviation weather service that I'm getting our live feed from here, or will be shortly. And we see that that's still broken. So let's fix that first. So I'm going to just kill that running from my browser. And then let's see, is this the right? I think I went over here. I actually set that behind the scenes. I'm not going to show you my key. It's super secret. I'll be changing this anyway, but just in case. So I'm just going to go here to the desktop, config service, and we'll do a Maven Spring boot run. And we'll just run it here from our terminal, which grabs that environment variable and allows us to decrypt those values. Hopefully, we'll find out. Too soon. Okay, so you can see here that we now have this decrypted. And by the way, this is my secret token. Please don't use this. Get your own, they're free. I'll be changing this again after the workshop. But I mean, this allows you to see that this indeed does work. It's decrypting this. Now, how do you do this, right? How can you encrypt and decrypt values? Well, that's pretty simple here. So let me see if I can do encrypt. Helps, spelling helps. Just see if I can pull that up. There we go. Good, so I don't have to type that all by hand. So if I encrypt something, and I want to make this, actually no, that's the wrong one. That's HTTP. I tried to do that, and that's just more trouble than it's worth. Curl -b, nope. Localhost 88, there it is. Okay, so that gets us the decrypt. So let's go here, and let's encrypt a value. And actually, I should have gone there to begin with, but that's fine. So I'm going to encrypt a value. We'll just call this our little secret. And this comes back. So our config service using JCE is giving us a value that is an encrypted value. So what we would do is just place that in one of our YAML files in our repo, and we would commit it, push it, and then restart the config service or issue a refresh, if you will, and then that would be available. Now, if we want to decrypt that, so let's see, we'll do a decrypt. It is just not going to pull that up. That's fine. That's fine. We'll do this the hard way. Decrypt. And then I'll just paste that. And we see that it's our little secret. So that allows you to, just using a live config service, to encrypt and decrypt your values, which is kind of nice, right? As we get into the cloud platform, we'll see how to make that a little more rigorous, but that gets us a pretty good start and is useful in a lot of circumstances, just kind of out of the box. Okay, so we know that's working. Everything seems to be up and running just fine. Let's go ahead now, and we'll develop the next thing, which is our service registry, so our applications can then find each other. Multiple instances of our application can then find each other. So I'm going to change this to discovery service and make this our disco service. Everybody still good, right? With me? Yeah, good stuff on the config service. It's such a minor thing, but it's super critical to everything else that I like to give it at least a little bit of attention on that front. So I'm going to remove the config server dependency. I'm going to bring in the config client dependency and then our discovery service. So again, use Eureka underneath. Let's generate this and drop that in the same spot. Once again, go out here, open that. All right. How are we doing on time? We're good. Yeah, I don't want to like run too long, each time before I take a break, but I think we're still good, right? Okay, carry on. All right, so the first thing, once again, I like to pull up the POM. The POM's there. Again, we only have two dependencies, the starter config and then the Eureka server. All good there. Now here, key, there we go. So I'm going to define what my Spring application name is. And the reason I do that, we'll just call this discovery service, is because once again, if I go out here, we see that we have a discovery service YAML That's not by accident, right? Anything you identify a service, and it doesn't matter if you have 100 instances of that service, when they identify themselves to the config service as a discovery service, they'll get the exact same properties. So that's good, right? So I'm also going to point to my Spring config import, config server, http://localhost 8888, because this is where I'm loading all this and I'm running all this locally. Now, at this point, well, or you will very shortly perhaps, be wondering, why am I doing it this particular way? There are a couple ways you can do this. You can either go config first or discovery first. So what I like to do is config first, and here's why. There are again, there are trade-offs, right? There are pros and cons. So if you go config first, that means that our discovery service can use the config service to provide its properties as well. Kind of makes sense, kind of nice. If you go discovery first, then every other service can use the discovery service to find the config server, which is nice. That's very nice. But for the discovery service, it has to provide its own properties, because at that point, it won't know about the config service until it registers with the discovery service. So trade-offs, right? There's no, quote, right answer. There are just trade-offs, so choose what works for you. I like this approach, because then everything relies on the config service, but again, your mileage may vary. So let's go here, and let me pull up localhost 8761, which is our local dashboard. Oops, I've got that blown up a little much. All right. And this, again, is another area that your mileage may vary. I have the discovery service registering with itself as a client. This can actually be useful when you have multiple Eureka instances running in different regions, for example. But when you just have one, it really doesn't give you much. But what it also allows me to do is set some other properties that I want to do for check-ins, for the health checks from all of the other services. So I kind of bundle those two things together. Again, your mileage may vary. This doesn't give me a whole lot of value at this point because it's just telling me that it finds itself, but you know, it is what it is. There are other values here that are shown. They're kind of interesting and useful to some degree. The total available memory, the CPUs, current memory usage. The really big payoff is right here in the center, because that's where you see all of the services and instances of services that you have running. That's where Eureka shows them to you. And then I also, at some point, I'll be showing you the last 1,000 since startup, but not just yet. That's just something else coming up. But here is where we want to focus, and this is where we get into our different services we're building to build out our portfolio of microservices. With that, let's take maybe a quick break. Let me ask this. Are you good with carrying on? Because the next stretch, I kind of get on a mad tear, and I don't want everybody to be looking at the door going, I've really got to go. So do you want to charge on, or do you want to stop for a couple minutes? Keep going. All right. Any dissenting voices? The ayes have it. Okay, so with that, let's get into the fun of building out our portfolio. Closed. All right. So let's go back here to our Spring Initializer. I'm a pilot, so I like to talk about piloty stuff. But really what it comes down to is anytime you do a demo, anytime you build out something that you want to show working, data is good. If you generate the data, it's still good, right? But when you have live data, it's just more fun. It's more real. I mean, that's when you see stuff happening. So I like to use live data when I can. So I found some different APIs, some different services that provide live data on demand. So that's what I like to use. And of course, it has aviation focus. So I used to do coffee all the time, and I would get really great coffee recommendations, but I never could find a really good live data thing on coffee. I always had to generate like orders myself, which wound up meaning a lot of coffee to drink when I'd go to pick them up. So, wow, really tough crowd. Okay, so, or else you're going, that doesn't sound like a problem. I don't know. All right, so let's build out some applications, some different services. I'm going to, again, use the same stuff. I'm just going to change a few basic things. I'm going to create, for starters, an airport service. We'll call this, again, airport service. And I don't need this to be a Eureka server, so I'm going to remove that. Same Java version, same packaging, etc. So I'm going to add a couple things. I want this to be a discovery client, so it can interact with our service registry, right, and find other services to interact with and deal with. And then I want to add a few other things like a reactive web API. By the way, if you're not using reactive streams, libraries like Project Reactor, if you're not using publishers and things like that, that's fine. Loom is changing the landscape, or will really, when it, I mean, it's here, but it's going to take a little while, I think, for things to be fully apparent on how it affects things. But the reactive web components baked into Spring allow you to interact with imperative, with blocking and non-blocking endpoints. It gives you that flexibility to deal with things on either side. So I bring them in. If you don't like dealing with reactive streams publishers, that's fine. I'll do that in the demo, but it all works pretty much the same way. So it's just a kind of an elegant way to do it, I think. So I'm going to bring in Actuator because that gets us our things like, as it says, built-in or custom endpoints. It's kind of that production-ready stuff, so you can see what's going on inside your application. I'm also going to bring in reactive Mongo because I'm going to be storing some things in this particular service locally. So this is an airport service. How often do airport runways change? Yeah, I mean, it happens. You have magnetic drift, but that's over the course of like years, usually decades, right? So runways don't just change overnight. Runway designations, runway lengths, things like that. So what I like to do is grab those values once on a call to the external API and then have those here locally. Doing things like weather, as we'll get to shortly, that changes, right? So we want that always to be fresh and live. But I'm going to be storing that locally. Let's see, I want to also bring in Sleuth and Zipkin. So Sleuth, as it says, gives you distributed tracing via logs, and then Zipkin allows you to basically do something with it. You don't have to use Zipkin. There are other ways to harvest your logs and represent what's going on across your applications. Again, I'm using the foundational concept here. Now, this is one thing that will change with version 3 of Boot and version 6 of Spring Framework coming out, particularly version 3 of Boot. So this will go away. Sleuth will not be used as the underlying distributed tracing feed, if you will. Micrometer will be used for that. But currently, this is the latest, greatest state of the art for current versions of Boot. And not a whole lot will change as far as the mechanisms of the concepts, just the underlying libraries. So still relevant. I just wanted to make you aware of that in case in a few months you come back to this and go, wait a minute, what happened? Who moved my cheese? So there we go. So let's go ahead and generate this. And once again, we'll unzip that. And open that up. And open that up. Come on, IntelliJ. There we go. All right. Once again, to really quickly check the dependencies, everything's good. I like to do a quick check, as well as have those here handy. Go to our application.properties. Once again, we'll have our Spring application name. In this case, it's our airport service. And then our Spring config import. We're going to point to a config server here. And by the way, you do have options for your configuration properties. Again, you can have a config tree, your tree that is present within Kubernetes, right? You have, well, specifically for this, Vault as well. You can use a JDBC connection, as I mentioned, SVN. Is anybody still using SVN? Oh, dear. All right. I have a T-shirt up here for you. You can use that to catch your tears, right? Yep. Right. It happens, right? I mean, as much as we like to talk about the latest, greatest, I mean, there are a lot of solutions out there that just work or that you just can't migrate off of due to inertia. You've got a lot of, kind of that critical mass of stuff in it or in other cases, built using it. So, it is what it is. It's not always glamorous, but as long as it works, as long as it doesn't obstruct your getting things done, right? Okay. So let's build our service. Now, I like to start with the domain. So let's start with the domain here. So I'm going to create a record here for airport. And what do we keep track of in an airport? Well, we know we're going to be storing this airports in Mongo. So I'm going to make this a document. And I'm going to indicate this as an ID. And we'll call this an ICAO code for our identifier, right? ICAO, International Civil Aviation Organization, right? So every airport is assigned an ICAO code that's unique throughout the planet. So we'll use that. And then let's see, what else? So I'm trying to go off memory. If I flake here, I'll just have to look it up. But we have, for each airport, we capture the city and the state that the city, and by the way, I'm using local to me for my hometown, a set of airports that are your towered airports within, I think it's 50 nautical miles of St. Louis. St. Louis, Missouri, center of the U.S. Anybody heard of it? St. Louis Cardinals, any baseball fans here? Cardinals are in the playoffs. The World Series. We figured out that the way to be world champions is just not invite anybody else, right? So anyway, that's another discussion for another day. But, Cardinals a great team. So if you follow baseball, you've probably heard of it. If not, why? Why? So let's see. So we're going to also have our elevation in feet. By the way, you're probably looking at that going, feet, that's quaint. And then the next thing you notice is, why are we storing the number of feet of elevation in a string? I don't know. This is an external API. I'm just consuming it, right? So it's a funny old world. So let's see. And then also the name of the airport. I also want to keep track of where it is, right? The latitude and the longitude. And then I also want to create an iterable of runways, because you'll have a runway or runways that an airport has, right? So that leads us to the next thing that I need to keep track of, which is create a record for runway. And each runway has, let's see, an ident 1 and an ident 2. I always forget that. So the reason, well, let me go ahead and do this while I think of it. So you have int, and this is length in feet, of course, and the width in feet, of course. Okay, so why ident 1 and ident 2? Well, in airport speak, anytime you have a runway, it can be used both directions. Kind of makes sense, right? You have one massive piece of pavement. So, I mean, there are exceptions. There are rare exceptions where you're based on noise abatement or buildings or patterns, obstructions, things like that you just can't use it the other way. But generally speaking, a runway, you can go either way. You can land or take off from either direction. So let's say it's north-south runway, right? And it's compass, so it's 360 degrees. So fully, pointing north is 360. There's no 0, it's always just 360. And for runway numbers, you take off the last 0, right? And it's to the nearest 10. So it's runway 36 points due north. Well, the same runway going south is runway 18. Kind of makes sense. You may have slightly different lengths because sometimes you have a displaced threshold and things like that. But generally speaking, it's one runway going both directions. Same thing if you have an east-west runway. It's 09, 27. And it's always numbered the way you're heading when you land on it or take off on it. So there are 2 idents for each runway, and then the length and width in feet. Now we're going to be storing these things, just a little extra credit trivia. We're going to be storing these things in an airport repository, and we will extend our reactive CRUD repository interface defined in Spring Data. We're going to be storing things of type airport with IDs of type string. As we can see here, this is our ID field, right? So it's a string. And now let's build a service that we can use to, we'll call this airport service, to interact with things, right? To provide our airports. And this is both an internal facing and an external service. I'm going to be using it to store and retrieve things with our data store, as well as reach out to our external API to get stuff. So in order to reach out to our external API, what I'm going to do is create a bean here, and this will be a web client bean. Client return web client dot create, and we'll point this to our external API, wx.rest, and we'll point to API stations because that's cleverly enough, interestingly enough, what they call our airports at this API. Some of the things are weird, the elevation underscore feet and things like that. Stations versus airports, it is what it is, and I'm too lazy to change it, so it's fine. I'm going to inject here our web client, right? So we can do something with that. And I also want to inject our airport repository so I can do something with that. And then let's go ahead and create our constructor with both of those, so it will inject those for us. And then we need to have our token, our super secret token, to access our external API, our AVWX REST API. So I'm going to just pull that in. We know we've got that defined in our properties, right? Value. So I'm going to pull that in here, if I can type, and AVWX.token. Now, what happens if it's not present? well, it usually chokes. But what I'm going to do is just put a little message to myself here. So if it doesn't have a value, it puts this in instead. So it'll still go ahead and run. It'll give me an error when it tries to reach out, but it'll log that so I can see that in my logs. No valid token. And then I'm going to assign this to a token variable there. And that gets us ready to interact with our service. So what kind of operations will we want to be able to do? So we want to be able to return a flux of airports. Those of you who aren't familiar with Reactive Streams publishers, I like to it's an imprecise parallel, but I like to compare them to their blocking counterparts. So if you have a method that returns one thing, potentially one thing, it'll return an object of type T. That's 0 or 1. It may not have anything to return, or it may have a single object of type T. You can think of it sort of like an optional, I guess. But if you also you have the option returning from a method, let's say, to return an iterable of type T. So you can get 0 to n values of type T. What is different about the blocking mechanism is that it will have to assemble all of those to return them in one thing, right? In one go. So you can return maybe 5, 8, 10. That's no big deal. But what happens if you have thousands? It has to build that before it sends it back en masse. So with Reactive Streams publishers, there's no waiting. So you can get that mono in reactor speak. You can get that mono, which is 0 or 1 values, and it'll be coming along forthcomingly when it's ready. Or if you have a stream of those values, maybe just thousands, or maybe they're just continuing 1 per second forever, it will send those back as they come in, right? So you're not waiting for them all to be assembled before any of them come back. So a flux is sort of like a reactive iterable. So that's where the parallels end. But so we're going to return a flux of airports, and we'll say get all airports because we want to be able to provide the capability of returning all airports. And I'm just going to return our repo because we're going to have these stored in our repo, find all. And this is a method defined in our Spring Data Repository interface. I'm going to build on that, by the way, every chance I get, because whatever's written already is a nice way to go. I can't mess that up. I want to also be able to return a mono. Again, that 0 or 1 values of a particular airport. Get airport by ID. And we'll pass in a string ID, return repo.find by ID. Now, those kind of cover the very basic elements of dealing with our internal repository. But again, we need to reach outside and grab that list of airports so we can bring them back in. So I want to be able to choose an airport, say, give me the information for that airport, and then do something with that. So here we have public mono airport, and we'll call this retrieve airport so we can make it clear that we're reaching out and retrieving that from outside. Retrieve airport, string ID, and let's see, so return, and we'll use our reactive web client to get that. We want to add to the URI, because I started off here with a base URI, right, of API stations. But what I want to do is add to that. So I want to add the ID for a particular station, right? And then I want to add token equals so I can pass in my super secret token and be able to use that API. So I'm going to pass in the ID and the token, and then we'll retrieve that and we'll assign that to a mono, again, one thing of type airport. And let's just log it. I like to log things as I go. I just don't like to overlog. So I think that's not a terrible balance to strike here. All right, so there's our service. So that's our internal API, if you will, and being able to reach out and grab that as we need to. Now I want to create a REST controller here, request map. By the way, before I get too far down this path, I will need to come back and do something to actually reach out and grab those values and pre-populate. So I'll come back to that in a moment. So this will be our airport controller, and 2 L's, please. And then I want to inject our airport service to be able to use. So private final airport service. And that's probably good. And of course, spelling counts here. Airport controller. All right, so let's inject that. And let's build out our API. So we have a get mapping, and I want to be able to return just off the bat, just as a default, all airports, right? So we'll call this public final flux airport airports. Return service dot get all airports. Okay, this is a pass through, at least initially, right? Get mapping slash. So it may be useful to return a list of airports, just their names, but not the full airport details, right? So public final flux of string, because I just want to return a bunch of strings in this case. Airport list. There we go. Return, and I'll do the same thing, service.get all airports. And then what I want to do is map each value that comes back to, and we'll just print this out, do an ICAO plus, and then we'll add the airport name. And then just to make things nice and formatted well, I want to just give it a line feed there. And then we will, let's log that. Yeah, should work. And I do want to log this too, because that way we can get some logging in there. And then I want to be able to pull up externally a particular airport. So we'll do a get mapping slash airport slash ID. And we'll return a mono of type airport. And we'll say this is just airport by ID. We'll use a path variable, of course, as I indicated above, to return a particular or ask for a particular airport. Return service dot get airport by ID. We'll pass the ID and log it. Right? It should work. Sure, why not? Now, I do need to add some values in there. I need to add the default set of data and go ahead and pull that once. So what I'm going to do is just create a command line runner bean here. And we'll just call this load data. And we'll actually pass in our airport service, so we can use that, and our airport repository, so we can use that. Now, command line runner is a functional interface with a single abstract method. And since Java 8, what have you been able to do when you have a functional interface with a single abstract method? Lambda, right? Yeah, that's a little distant history now, but it's always fun to think about. So we're going to define the lambda that will define our run method in the command line runner. So I'm going to take the repo, and I'm going to just make sure we're cleaned out here first. I'm going to do a, not a find all, delete all. And then we will take a publisher, in this case, using then many, and we'll just create a flux of just these values. I'm going to cheat a little bit and not type in each of these values of the B, C, and D level airports in around St. Louis. By the way, every nation or group of nations has their way of categorizing size of airports. Class Bravo in the U.S. is the largest by traffic. It's towered, of course, controlled airspace. Charlie, one step down, still towered. Delta, one step down, still towered. Everything else is uncontrolled airspace, uncontrolled airports. But we're just going to pick the bigger ones for this. So we're grabbing a flux of just these values, just strings, and then I'm going to map each of those strings. And let's do a, so let's see, service dot retrieve airport. And of course, we can actually do better than this. We can use a method reference there. And I'll just flat map that. Oops, hit my key lock. And we'll use our repo, do a save all. And then what I like to do is subscribe and list this. Now, it's important to subscribe because a publisher, a ReactiveStream's publisher, if nobody's listening, it doesn't do anything. And that's by design, because if you can't have hot publishers. I don't want to get in that conversation right now either. But generally speaking, every publisher is a cold publisher. The reason being is you don't want to have a lot of cycles chewed up if nobody's listening. So until somebody subscribes, nothing happens. So we subscribe, and then I'm just going to log what happens here. So let's go ahead and run this and make sure that I haven't gotten any crazy typos in here as we went. And drink them if you got them. Get a little JVM warning there. And that all looks, oh, that, I spoke too soon. I started to say, that all looks really good. But let's see what we got wrong here. All right, so the token is good. API stations 404 not found from get. Oh, you know what? I think I do have a typo in there. Actually, I think it's just station. Let's try that again. If not, I'll have to consult the notes. Remembering public API is not always the best, easiest thing to do, but this should get us there, I think. Much happier. Yeah, I guess it helps. Typos are a bad thing. Computers being so literal, right? So we have all of these bits of data out here, but let's go out and check them out here, because this is where it gets fun. So if I refresh our Eureka service, and of course it's telling me, hey, you've got your timeout set where it can't guarantee that it's got a liveness check within the certain time. So it may be optimistically saying there's something up when it's not. I need to mess with that, but that's just a timeout. So we see that our airport service is here. So if I go here and click on this, we see that, and I actually plug this in. This is a very simple thing to do as well. You can add info endpoint and values to that so that when it goes by default to actuator info, it will pull this value up and just show you what your service is. Before I get into showing you anything about the airport service, I want to double back and hit a little bit of information about actuator. That might help, right? Sorry about that. So actuator is something that I've got fully exposed at this point. One of my properties in the application.yaml is management endpoint. What is it? Management endpoints web include equals star, which means even though you can secure actuator endpoints, and by the way, do that. When you're in production, don't kick down the door like I did on this. This is just for a demo. But when you're in production, you want to control access to it because your actuator endpoints give a lot, and I mean a lot of information about the environment on which your application is running and the application itself. So let's see, let me find, yeah, here we go, env. So let's go to the environment, and you can see right here your property sources, where they come from. All of your properties that your system reports, right, that it can get access to, your application can gain access to, are right here and served up to anybody who can get to this endpoint. Now, the good news is you can integrate actuator with Spring Security, and you can button this stuff down 7 ways from Sunday. It's really good. The bad news is I'm not doing that here because I wanted you to be able to see all this, but you can get to all of this stuff if you leave that door open. Don't do that. Actuator gives you a ton of information. You can create your own endpoints, create your own metrics, and that's super valuable and super helpful, but you don't want to generally leave everything available and exposed like I am here. So don't be me. All right, so let's go here, and we'll just go to our main. Let me back that out a little bit. So this is, as you might remember, the get mapping, which just brought back the full list of airports that are local to the St. Louis area, right? So we've got KMDH, we've got the elevation, the name, the latitude, the longitude, the city, state. We've got the runways identified again. And by the way, I didn't mention this. If you have multiple parallel runways, you can have a left, a right, and a center many times. In this case, it's got an 18 left and correspondingly a 36 right, coming back the other way, 18 right and 36 left. Then you have a 0, 6, 2, 4, et cetera. You notice these are all 18 apart, 180 degrees. Makes sense. So you get the full list. If we want to go ahead and try out some other endpoints, so we can go to our list. And by the way, this is terrible in a browser. It just looks terrible. So I'm going to go out here and do, let's see. So there we go, HTTP, which looks much nicer here, right? So this gives you just your general list. It's just the quick and dirty endpoint I created. And then if we go out here and we want to do a particular airport, KSTL, for instance. So that's Lambert International, and that gets us our information here. Okay, so that's kind of one of our backing services I wanted to create. Again, I'm reaching out to the external API. I'm storing that locally because we don't need, it's not going to change every few seconds or even every few days, every few years, maybe. But I wanted to store that locally so we can do something with that locally more efficiently. So the next thing we're going to do is go out and create a weather service. So we can start seeing how some of these things interact. So weather service, and I don't need to store anything locally because weather is a very dynamic thing, right? So we want that up to the second. Every time we query it, we want it to be live and the latest, freshest we can get. So that's what I have here. I'm just going to remove the Mongo dependency, and we'll generate that. Application, save it. All right. Cool. All right. POM, application properties. Once again, in this case, the Spring application name. This is our weather service, and the Spring config import, config service, config server, http://localhost 8888, and our application code, right? Once again, start with the domain. Again, that's the way I roll. So we're going to start with a time record, and for our time, we have a zone date time that we want to use, date time, and then a string representation of that. Everything is off Zulu time, just like it or not. There you go. Again, it's one of those interesting quirks. It's not local, which makes sense because you're crossing time zones so much. Let's see, what else do I want to get into? Well, we have a few things that I want to create. So a record for visibility, and we'll just have a representation of that. There's nothing fancy there. And then a record for wind direction. A representation, just a straight string representation. By the way, in aviation, it's still very expensive, very costly for bandwidth, right? So if you need to shoot information back and forth between a ground station or even a satellite and a moving target, data is precious. So everything typically comes through in a very terse, and it is very terse, string of values that are jammed together. And I'll show you that as we get our weather as well. But that's... so the string representation is something that is just you deal with. So wind speed we'll have. So for our weather, we want to have a METAR. Now, what you may ask is a METAR. A METAR is a meteorological aerodrome report. Current weather. It's just, I don't know why they don't call it current weather, but again, it is what it is. So we have a raw METAR, which is just that cryptic text. And then we have our time that the METAR is effective, right? And then we have a string for flight rules. And that's your instrument flight rules or visual flight rules, how good or how bad the weather is. So we also have a TAF. A TAF, why is that not doing that? Record time. Do you not see this? Oh, it just lost it because I was doing this, sorry. Anyway, so TAF. TAF is a terminal aerodrome forecast. So these are the forecasts looking out in the future, being wrong all the time. So that's something we're going to have to deal with as well. So for our TAF, we have a string for this. I may have to consult the cheat sheet. Let's see. So, Yeah, I don't think this is right, but we'll come back to this. So we have our, we actually just start off with our time, and that will be a start time, and then another time for when it's effectively over, right, end time, and then a forecast, an iterable of forecasts, forecast, only it's not, it's forecast. Welcome to the lovely world of public APIs, and that is with an E, because I can't spell apparently. Okay, so we have a forecast, and what is in a forecast? Well, we have our raw representation of it. We have our, let's see, so we would have a start time, end time for that too, I believe. So time, start, time, end time. And then we have, we have our visibility, right? Visibility, our wind direction, which is wind underscore direction. Again, public APIs, love them. And wind speed, glad it's there though, wind speed. And there's more, but I'm just kind of skinning it down. So hopefully that's right. If not, we'll come back and fix that, because why not? And let's go ahead and create our REST controller, request mapping / by the way, you don't necessarily have to specify the request mapping if you're going off the root. But I find that when you, and this is a little aside that we're not going to deal with today, when you start generating native images, it's very literal about that kind of thing. So you want to make sure that you get in the habit of doing that even when you don't necessarily have to now. So just a good little extra to remember. So this will be our weather service and our weather controller. And in this case, once again, we're going to need to hit that external API. So I'm going to create a bean here for web client, client, and return web client.create https avwx.rest. In this case, we're going to be building off of the API URL and taking it from there. Once again, we're going to be using our value here. And this is the AVWX token that we're going to pull in. Token, no valid token, and private string token. And then, of course, we need to have our web client that we inject. Nope. There we go. Now, let's build out our API. So get mapping. In this case, for our weather controller, we want to be able to retrieve a default. So I'm just going to say public flux, public final. Actually, this would be a mono, right? So mono of metar. So the current weather conditions. So retrieve default metar. And we'll come back to that. I want you to do a get mapping where we can point to a particular metar for a particular airport. So public final mono metar. There we go. Retrieve metar. And we'll retrieve this, return client.get. And we'll add onto the URI, of course, /metar/ ID, and we'll add the token, of course, because we have to have that. Token equals token, and we'll add the ID and the token. We'll retrieve that, and we will convert that body to a mono, in this case, of type metar, and we'll log the results. Okay, now if we want to provide that default, all I'm going to do is just return, retrieve metar, and we'll just pass in KSTL, which is our central airport. And then if we want to grab the terminal aerodrome forecast, I'm going to do something I'm not proud of here. I'm just going to copy paste. Shh. Good thing this isn't recorded, right? All right, so we'll grab the TAF here, not the TARF, the TAF. Return a TAF. And we'll TAF that. TAF. And that should do it. Now, as long as I don't have any typos, that should work, right? Oh, I do have a typo. Oh, dear. Oh, yes, because I didn't indicate that this actually has a string ID. Whew. Typing's going downhill. I think I need more coffee. And once again, here, path variable string ID. That should make that considerably happier. Okay. All right, now assume I have all my variables correct. Let's go find out what happened here. So we'll refresh the Discovery service. We see here that we now have a weather service reporting. That's good, right? So let's go here, and let's just pull up our default, which is KSTL. So that looks good, right? By the way, this is a cryptic string. I was telling you about the raw values. So this tells you the ICAO code, and then the 11th day of the month at 0751 Zulu time, or UTC. The winds are out of 1/8, so out of the south, directly out of the south at 8 knots. There's their nautical miles per hour. 10 statute miles of visibility. Visibility statute miles, go figure. Ceilings are broken at 6,500 feet above ground level. Broken again at 10,000 feet. You add 2 zeros to everything. 20 Celsius is your temperature. 10 Celsius is your dew point. And other stuff we don't necessarily need for the remarks and all that. Okay, so that all works. So now if I want to grab the metar for KSUS, Spirit of St. Louis Airport, which is nearby. That works. And then if I want to grab the TAF for that, same airport, TAF, just make sure we've got all our endpoints exercised. So we have our start time. That looks good. Forecast, once again. So we see here that there's a start and end time. So this is on the 11th day at 0800 Zulu, UTC, to the 12th day of the month at 0600 UTC. Here's what's expected, so on and so forth. So we know that this is working, right? So we have an airport service, which goes out and grabs all of the airports in a particular area and saves them so we can pull them up quickly and reference them. We have a weather service, which each time goes out and gets current weather for a specified airport or the forecast for a particular airport. So now it's time to really kind of tie it together. Everybody still good? Do we need a break? Still good? Still good. Okay, so let's charge on. All right, I'm trusting you. If anybody has to excuse themselves, that's perfectly fine. We will take a break here momentarily before I get to the really cool stuff. I feel like there are several levels of cool here. So we've got our airport service, we've got our weather service. Let's tie them together with a condition service. And this allows me to pull up the current conditions at all of the towered airports in a particular area, right? The ones that we have that we're already storing in our airport service. So I'm going to just change this to conditions service. Let's see, config client, pretty much everything that we had, we're going to need. So let's just leave that in place. And I'll store that, and we'll go out and grab that, open that. Close that, open our POM. Come on, there we go. Go to our application properties. Once again, our Spring application name. In this case, this is our conditions, service, and our Spring config import. Once again, is config server, http://localhost 8888. You can see why some folks actually do the discovery service first, right? Because if they can find this through that, they don't have to specifically indicate what their config import is, their location of it. But again, then you have the downside of the the discovery service having to have its own properties stored up. So again, trade-offs. All right, so let's go here to our application code. I'm going to keep this model just a little bit simpler, so we'll have our record for airport. In this case, all I really care about is the ICAO code. So that's sufficient for our needs here. And then, of course, our METAR. And then our METAR requires the time, of course, so record time, and this will be a zone date time, DT, and a string for the representation of it. And that's fine. And then for METAR, let's see, what do we have? We had our raw representation and our time, which will be time and string for flight rules. And that gets us what we need for this. Now, this is where it kind of gets interesting, because I'm going to once again create our bean, right, for our web client. And well, no, I'm going to create a bean for our web client builder, because this service, our condition service, is going to be using two other services, right? So I'm going to show you kind of the manual, well, semi-manual way to configure that to give you the capability to interact with our other services while still using the constructs, the scaffolding that we've already placed into effect. So I'm going to call this builder. And by the way, I need to make this, since we're overriding this, by default, Spring Boot will create a load-balanced web client builder bean, so you can create these load-balanced web clients. But since we're overriding that, I need to annotate that likewise myself. So return web client.builder. And there are a couple ways to do this. I'm just going to do it this way for the time bean. Wow. Okay. More coffee. All right. So, or better jokes. I don't know. Whatever. I don't know what the problem is. My wife tells me I'm hilarious. I'm not sure what she means by it now that I think about that, but that's fine. Conditions service. No, this is our conditions controller. Now, so what am I going to do? So I'm going to inject our web client.builder. Yeah, that is fine. Now, I also, though, since I'm going to be dealing with a couple of different other services, what I want to do is define those here. So private final, web client, and we'll call this our airport client, right? And I also want to deal with our weather service, so I'm going to create a weather client. Now, what do I do with it? So I'm going to say our AP client equals builder dot base URL, and I'm going to point this to our airport. Let me just scroll that up, center it for dramatic effect. Airport service dot build. Now, this doesn't look like a correct URL, right? But it actually sort of is, because it's using our discovery service to say, give me an instance. I don't care which one. Just give me an instance of the airport service so I can talk to it. So we're going to do the same thing here for our weather service, weather service. And we'll make this our weather client. And now we should be able to use that to good effect here. So I'm going to create a get mapping. And in this case, I'm just going to just create a string, and we're going to do a liveness check for this, liveness. So return good morning DevOps, alive and well. Smileys help. All right. Oh, let's go crazy here. Come on. So let's see. Coffee. Now we're alive and well. Okay, so now I'm going to do a get mapping, and I want to produce a summary report on this, so public final. This will be a flux. No, not flushable. There we go. I did grab flux. Interesting. Flux of meters. So I'm going to return, again, the current conditions at the airports, the larger airports in the general area. So get weather for towered fields. Yeah, I like long method names. Obviously, we work with Spring, right? Those of you who don't recognize that remark, please go in and look at the Spring Framework source code, or Spring Boot source code, or Spring Data source code, or any of that. And this will look really short. I mean, this is a tiny, tiny little method name right here, right? I mean, we could do better, right? Get tower fields in the area of St. Louis, Missouri. All right, that's more like it. Okay, so what are we going to do? We're going to hit our airport client first, and we'll do a get, retrieve, because we're going to get everything that we can get, right? And that just gets back our full list of airports that we've got, right? And then I'm going to flat map each of those, body to flux, actually. I'm going to convert that to a flux of airports. And then I'm going to flat map each of those. So I'm going to take each of those airports, and I'm going to use the weather client to get something, but I need to add on to the URI. So slash ID, right? ID airport.icao, right? That looks like that should work. And then retrieve that and convert that body to a mono, in this case, of type meter. It's as simple as that, right? So notice that I don't have a token. I'm not dealing with the token anymore, that encrypted token, because our airport service has to keep track of that, right, to reach out and get what it needs. And the weather service needs to keep track of that and get what it needs. But I don't have to worry about the condition service. It's just calling the other services and pulling together what it can. So let's go ahead and run that. Hopefully there are no typos. And then once we get this done, assuming this works, and if not, we'll make it work. We'll fix it. Then we'll take a little break, and then we'll come back and we'll start looking at how that kind of ties all together, right? So we got our condition service, and I can go over here, and we can look here once again, and we see that condition service does show up. So let's go ahead and access that. We see the condition service and the actual endpoint, or info endpoint. So if we get the, if we do this, we see that, yes, we are indeed alive and well. We have coffee, so life's better. And then we'll go here, and then we will do our summary. Typos. What? Clearly, there is a typo in here. So let's see. Airport client get, right? We're retrieving those values, converting the body to a flux. We flat map each of those values to the weather service. We take the, let's see. /meter/ID. ICAO, retrieve. Computer is so literal. Okay, so let's do this. And we'll wipe that. By the way, I close this out because, and this is by design, each time I go to Eureka, it assigns a different port because I'm running this locally, right? But it can put this in a cloud environment. It can put it in different places as well. So I go back to my source of truth here in my discovery service to get that where it is now. And again, even if this goes offline, our applications have those values cached. So while this is coming back online, they're still able to communicate. They're still able to do things. It's resilient. So here we go here, and let's do our summary. That looks a little better. There we go. So now we can see that for KSTL, here are our current weather conditions. Same thing for Decatur or Springfield, et cetera, and so on. So it all works. Inexplicably, it all works, right? Okay, I'm going to stop here and just take, 10-minute break if we can all get out and get back within that time. If not, maybe a couple more minutes, but let's keep it as tight as we can. And then we'll come back and we'll tie together some interesting things, talking about gateway and tracing and deploying to cloud and things like that. So see you back in 10. Okay. All right. Yes, we're back on. A few things. One, I can't believe I did this. I completely forgot to get a photo. I always like to do this so I can prove to my boss I'm not just out goofing off and drinking coffee the whole time. I mean, obviously there is a lot of drinking coffee that goes on. I mean, those of you who know me know that. But I like to prove that I actually do some real work at times. So if I could get a photo of everybody, so, prove that we're here. So I doubt we'll even be able to see this because I'm a terrible photographer. But if you would just say, Spring. Really? Oh my gosh. For real. Okay. All right. So, Spring. Terrible. Okay. So that'll work. At least I have documented evidence that I at least showed up for a minute or two in this room and ran up on stage. And anyway. Okay. So, before I get started back into things, this is as good a point as any. Does anybody, and I've fielded a few questions before break and then a couple after, but does anybody have any questions just to toss out at this point? If you don't, that's cool. I mean, I'm going to talk some more, but if you do, let's... Oh, yes, sorry. I was looking all around. The lights are terrible. Yes, sir. Hello. I'm sorry, I didn't hear anything you said after the whole, Spring, we love Spring. Oh, I'm kidding. So Node, huh? That's tough. No, there are, like most options, there are sidecars you can use to interact with Eureka for applications as well. So I haven't actually done that in quite a while, to be honest with you. So I'm not sure how vibrant and active those capabilities are. But I know I had done it. I know it does work or had worked. So ping me afterward, and I'll try to get you the up-to-date resources on that. That's a good question because the idea was that, yes, you're going to be using Spring Boot applications for the vast majority of this, but there are going to be occasions you want to interact with Eureka and provide information and get information as far as locations. Now, I mean, it is all HTTP-based interaction, so you can tie in or hack in, so to speak, to the API yourself. But there had been in the past a sidecar you could just run with your application, which would handle that to gather the information, register, and to gather other registered instances of other applications. But yeah, ping me afterward, and we'll find out the resources, find out the current state of that, because that I just don't know off the top of my head. Used to work. I suspect it still does, but I can't say categorically. So. And we will talk, even though you did say Node.js. So, anybody else? Going once, going twice. Okay. If you have a question you didn't think of or didn't get your hand raised, or I just didn't see it, ping me afterward, or at the next stopping point, which will probably be afterward, or at the end anyway. I don't think I'm going to take the full. Looks like 68 minutes of time. I'll take probably a good chunk of that, but then there will be a QA time at the end and just a general kvetching and talking, so all is not lost. One thing that I forgot to show, and I have kind of an outline that I like to follow. But I forgot to show this, which is why I referenced the outline, so I'd find anything that I may have missed in the earlier stages. I mentioned this earlier, the last one, thousands in startup, and I forgot to go back and actually show you what that is. So this is a kind of a nice thing. It shows you the any canceled leases. We had to restart airport service and condition service a time or two. And then it shows each time something connects and registers itself, which is not huge, but it is kind of nice to see what's going on behind the scenes when it comes to your discovery service. So I do like to show that. And what happened there? There we go. Oh, sorry, I'm not in the right spot again. Home. There we go. Now we're back. Whew, had me a little concerned there for a moment. Okay. Just a quick recap. What do we have? We have our config service, which is serving up configuration properties to anything that asks properly and nicely. We have our Eureka discovery service, which is allowing our other services to see and be seen. They register with Eureka. They get the listing of other services and locations for other services, and then they interact with those from Eureka. Eureka is not the channel. It's not the bottleneck. It is just a service registry. So once a client application says, hey, I'm here, and tells Eureka where it can be found, and then occasionally polls it and tells it, yes, I'm still alive out here, it grabs the listing of other services it can interact with from Eureka. That's why I said if Eureka goes down, if the discovery service goes down, these services are still out here talking to each other, and it comes back up, and then they resume, polling and refreshing and stuff as it goes. And that's if you only have one. Obviously, you typically don't deploy just a single discovery service, but even in those circumstances, you have a resilient architecture with your microservices. Let's see what else. Then we, just to go on and give you the catch-up, we built an airport service which polls and grabs all airports within a 50 nautical mile radius of KSTL, which is my home airport. And then we have a condition service, a weather service, which will allow us to get current weather conditions or future weather conditions, as the weather forecasters like to call them. We all call them lies and hopeful suggestions. But anyway, so we can get those up to the second whenever we poll, real time. And then we have a condition service which ties those together. So the area, towered airports in that particular area, we can grab the current conditions and see what's going on. Let's see, that's pretty much where I left off. Let's go on now and do our gateway service, because I mentioned that, well, you know what, let me do one thing really quickly here. It's just a very quick diversion, because I wanted to show what happens when you have, let's see, we have a condition service, we have an airport service, because somebody mentioned the whole scalability thing. Now, I'm doing everything manually by hand because I'm doing this all locally. Hopefully, you'll have a platform out there which says, hey, looks like you're getting slammed on this service. I'll go ahead and scale out and add another instance of it, and another and another. Oh, now we've got way too many instances for the workload we have. We're going to bring that back in and kill off some of our instances. I'm doing this all by hand, so I am your platform scaler. But in this case, I'm going to go ahead and I just spin up another instance of our airport service. I'm going to allow parallel run, and then I'll actually stop this because otherwise I get lost in my thoughts and forget that I've done so. But for now, I want to show this. So we're going to start up another instance of this and just show you kind of what it looks like in Eureka, how Eureka treats it. We're still going. Yep, all right, so refresh. So now you can see that we've got a couple of different airport services here. And I will go ahead and, can I do that? Yes, I can. So there's one of them. And I'll go ahead and click to the other one, and we've got each individual one shown up here. And of course, they work just the same. Let's see, so I'll do that. That's fine. Same thing here. But if you notice, when I'm running this locally, let me zoom in on that. So of course, we have the same machine number, of course, but the port is what distinguishes, in this case, running locally. So you got two different port numbers. And that's just how we distinguish it when it's a local installation. Obviously, when you're running on a platform, you're going to have two different, completely different addresses, but it's still tracked the same or similar fashion through your discovery service. And then when you hit the condition service, it will route accordingly, round robin by default, to get the airport information it needs from whichever one. Okay, and then of course it tells you there are two running. Makes sense. All right, now I'm going to go ahead and shut one of those down so I don't get distracted with that. Whoops, let's see. And then, yep, terminate that, and I'm going to go ahead and set this back so I don't start parallel runs again. Not a big deal, but that way I can actually keep my thread going here. Mental thread. Okay, so that is a very, very quick segue or side tour of how different instances are represented within Eureka, within the discovery service. And again, those things are cached when when a service goes out and refreshes its cache of available services from Eureka. Okay, the next thing I wanted to do is go back and create a gateway service. Because again, when you start scaling these things out, so whether it's 1, 2, 10, 100 of these different services, instances of each service, that scales very quickly. So if you have, let's just say we have 3 services, and if we scale out to 100 instances of each, that's 300. Now, typically in a microservices architecture, you're not just scaling 3 services. I always tell people that's not a microservices deployment. That's a good start. Because in many cases in most cases, you have, when you start teasing out a service from a monolith, and that's typically the way these things evolve, you don't just tease out a service. That may be how you intend to start, but what you find is that there are these clusters of services that interact with each other. So it kind of makes sense to tease out this small grouping of interrelated, interoperating, heavily interoperating services. So you wind up with a small grouping. And then build out from there. So let's say 5, 10, 50 microservices that you kind of eventually tease out that kind of makes sense to treat as a community, if you will. So, but this gets to be a matter of scaling. It also gets to be a matter of access because you're not going to expose every one of those via a public endpoint so that somebody external can access each one of those. It gets to be very unmanageable very quickly. It also doesn't do much for your security profile, your security posture. So Spring Cloud Gateway allows you to control access, in a security way of speaking. It also allows you to restrict the load, so you have rate limiters. And also you can incorporate circuit breakers and things like that as well. I'm not going to show you all that today, but I'm going to give you kind of a taste of this, as well as kind of the way I prefer to implement the Spring Cloud Gateway. Because I think it makes a lot of sense. Again, your mileage may vary. I'm already getting wispy here. One downside of drinking a lot of coffee, wow, that made a big difference, is that my voice gets raspier the more coffee I drink. So as you might imagine, most of the time when I talk, my voice is raspy. When I drink water, it's amazing what a difference that makes. All right, so so I'm going to change this to our gateway service, gateway service. By the way, I almost did not get back in here. I went outside just to hit the restroom, and the gentleman in the hallway, the hall monitor, stopped me, and he's like, "Where's your badge?" I was like, "Oh, I left it in there." He's like, "You have to go back and get it." I was like, "I just need to hit the restroom. You have to go get your badge." It's like, okay, but I need to hit the restroom and go back. And so I wasn't sure if I was going to get to go to the restroom, if I was going to get to come back. I wasn't really sure what was going to happen next. So I guess that was that quanta that we were, yeah, good to be back. So, okay, so gateway service. So the next person who speaks, if they don't come back, chances are it's just somebody has them pinned down in the hallway. Just a little warning. Okay, so for the gateway, I actually don't need or want to bring in the Spring Reactive Web dependency because what I'm going to do is add the gateway dependency. Spoiler, that actually includes the reactive web dependency, so you get it all anyway. But that allows you to build a Spring Cloud Gateway instance here. As it says, simply an effective way to route APIs, cross-cutting concerns, monitoring metrics, security, resiliency, etc. So I'm going to add that. We'll generate our application. Sure. All right. There we go. Okay. So now we have everything that we need. And if we go to our application properties, once again, our Spring application name is, in this case, Gateway Service. And our Spring config import, once again, config server, http://localhost 8888. And we go here, and yeah, that's it. Yeah. So one thing that I did want to say is that a gentleman came up and asked me right after break and just said, hey, look, is there any way to, and I won't go into the specific details of it, but is there any way to do more with the gateway, right? And there is. I mean, I can build out a REST controller here. Well, just do this. So this is our gateway controller. And I don't really, I mean, okay, this isn't really necessarily an anti-pattern to do something like this. So string greetings, return hello from the gateway. This isn't really necessarily an anti-pattern because all I'm doing is basically a liveness check, a greeting, whatever. But you can build out anything you want at the gateway. The problem is that the gateway, the more you load it down, the less gatewaying it does, and the more it actually is an application and provide functionality. So there are certain cases that you can probably envision that make some sense to put it here on the gateway. There are others that easily could overwhelm its intended purpose. So you kind of have that do one thing well. Now you're doing two or three things and maybe less well than you would if you focused on the one. So it's a matter of judgment, right? In this case, I'm not necessarily overwhelming it, but it would be easy to do so. You can also define routes in your gateway. I don't like to do that. A colleague of mine likes to do that, and I think it shows a lot of the power and capability of Gateway. But generally speaking, what I like to do, what I want to do, is let's go out here and cat the Gateway service. I want to put it all right here, right? Actually, let me pull that up in a browser here. Localhost 8888 and Gateway service, perfect. Okay, so I like to do that here because that way this is more dynamic, right? And it can be loaded, so no matter how many gateway service instances you have, or if you need to make this change, you're not in there tweaking code. Gateway service, one of the big advantages of it is that it is just a Spring Boot application. So it's nothing exotic that you're having to deal with. It's outside of the realm of your expertise. You're not having to deal with some weird archaic interface that's dealing with some, closed source, closed black box software, but it's easy to add complexity where none is necessarily wanted or warranted, and this is a way to keep it nice and tight because you can define your routes and define what you do with them. So if you come in and you have a load balanced endpoint for airport service, let's say a service, so it's referenced not to a particular instance but to any instances sharing that service name. You can provide this path for the gateway to know that it should route to the airport service, and then you can have any kind of filters. I just have a strip prefix 1, so it removes this first segment and then passes on what remains to our airport service or an instance of the airport service. Same thing with weather service, condition service, etc. I have a report service, which I haven't implemented yet, but it's there for the future expansion. And it allows you to externalize that configuration like we do with all of our other configuration. It's externalized, which has a few advantages, one of which is it keeps things very nice and clean in your gateway application. So if we go here, we can see that it now shows up in our discovery service. And if we go to the gateway itself, and of course I just have this hello from the gateway. So again, you can build this out any way you want to, but typically I just don't really recommend it. And then if we want to go to our airport service, and it just passes through, right? If I want to go to the conditions service, wasn't it conditions? And then a summary, right? Boom. Okay, so it all works. So let me go ahead and refresh that a few times. So Gateway just routes accordingly. All it is there for is to translate, filter, route, secure, hopefully, which I'm not doing any of that because I'm not integrating Spring Security throughout on all this, but you certainly can and should when you go to production. So this gives you the kind of the nickel tour of Gateway and what you can do with it. Now, what I want to do at this point is go ahead and segue, because one of the things that is a bit more difficult when you talk about breaking one thing into a lot of things is figuring out where problems occur and what to do about them, right? Diagnosing, isolating. When you have a monolith, and I actually cribbed this from one of the early Netflix folks. When you have a monolith, it feels simpler to troubleshoot because you know where the problem is. It's in the monolith. The problem is that monolith may have millions of lines of code, so it's not always simpler. It just feels simpler because you know where to start. In a microservices-based architecture, a distributed system, you don't always know where to start. You don't always know what normal is or where the aberration comes in. Because if you're having to hop, skip, and jump among several different services and pass requests and responses back and forth, you're not really sure why something that used to take a half a second is now taking 10 seconds, unless you figure out where each of those I don't want to use the term just yet, but each leg of that journey, whether it's expanded beyond where it should. So in comes things like sleuth and Zipkin, right? Or other mechanisms for seeing what is coming out of sleuth. So with these constructs, you have the ability to have a full trace. So from the instance of first, the initial request goes out. Each time that makes a hop to a different service and makes a call within a different service, or stores something in a database or retrieves it, etc. This forms a span within that entire trace. So you should be able to, once you assemble those, see the entire trace throughout and back and diagnose the amount of time it took or see the amount of time it took for each span. So I should have pulled this up before, and I just got excited about other stuff. So let's see. So 9411. There we go. So here's Zipkin. I probably have that blown up just a bit too much. So I'm going to run the query, and this is our largest duration. So if I pull up this one, and we see that this actually going through the gateway service, I got to access, I accessed the weather service, the conditions service, the gateway service, the airport service, and MongoDB. Now that looks promising, right? And this will go through pretty much everything, but I like to grab the largest one and show it first, which actually our performance is pretty good here. I mean, this is kind of incredible because it's reaching back to, I think, Oklahoma is where this thing is, where the FAA has one of the nodes and pulling this data. So the fact that it's doing this in a couple seconds, it's kind of impressive. Good Wi-Fi here. But anyway, so we're going through the gateway service. We see that the entire round trip is taking under 3 seconds, 2.825 seconds. And then it's going to the conditions service, pulling the summary. You can drill into this a little bit more, show each kind of the metrics that are important throughout here: client start, server finish, client finish. So that round trip, and it will tell you exactly the method that it's calling. This nice short abbreviated method name, very appropriate for Spring, right? And then you can go on down here in the airport service. We're getting a get, so we're pulling this from our local MongoDB install. And then we're going through and we're hitting the weather service with a particular ID, which then, of course, adds the token to it for that call. Oops, that's fine. I say it's a little fiddly on my my tapping on the my trackpad. I'm not used to using the trackpad now. I used to do this all the time, and then I stayed at home more, and then I got used to my mouse, so now it feels weird to me again. All right, so once again, we hit the weather service and grab each one of these. We can see that certain calls are longer than the others. Yeah, for whatever case, for whatever reason. But that gives us a way to kind of troubleshoot and go in. You can see at the top here that, I'll zoom in on this. Whoops, zoom in over here. So we see that each different step of this has a span ID, and that's the unique ID for that particular leg of the journey. And then it has a parent ID under which it falls. So the parent ID for this one is 13857, et cetera, et cetera. So if we go up here, 13857 for that span ID, and that span ID has a parent ID of BE29CC, which if we go on up here, BE29CC, et cetera, and that has no parent ID because that's the top of the food chain. So that, I'm using Zipkin for my visualization here, collection of visualization. Sleuth actually provides those traces, those spans and traces to the logs, but you can use whatever tool you want to actually dig into that as well. All right, so what else did I have to show here locally? Okay, so we're good there. I guess let me go back to the slides at this point because I think I've covered everything that I wanted to cover here locally and show you kind of from the ground up. While I do that, any questions? Oh, this isn't a Node.js question again, is it? Oh, I'm grabbing my coffee for this one. Okay, go ahead. I'm running this locally, just in a Docker container. But I mean, you can run it anywhere. Yes, yeah, I've got it. And by the way, I should have mentioned this earlier too. If you're not which you probably are, but if there's anybody in here who is not as familiar with Spring, Spring in general, Spring Boot especially, but any Spring projects are very much developer first focused, which means that they focus on the development experience above all else. Because, and it kind of makes sense to do this, if you were going to have defaults for a deployment target, you wouldn't go to production with that. You wouldn't have a default in there for production because literally everybody's production environment is different. And even your production environments, if you have 10 different things where you deploy 10 different things, different targets where you deploy 10 different things, even those will differ. However, your development environment typically is done locally. Now, we're seeing some change in that regard. Jury's still out on that. But most development tasks are done locally. So it kind of makes sense to optimize for that experience. So with Zipkin, I didn't have to provide any specific way to locate that because it's using the default location, which is localhost port 9411 for the visualization on that. Same thing with Discovery Service. Even though I have it where you can actually provide that information through your config properties, I don't have to specify exactly where to find that because it's all running locally, which is localhost 8761. So it's very much centered on making you more productive as a developer. But of course, when you deploy that to production, there are a few other properties you have to set. So you're not seeing those properties because they're not there in my circumstances, but they will be when you actually go to production. Make sense? Cool. Okay. There are so many things that I want to mention, and I actually should list them by bullet point because I typically just kind of narrate those as I go, but that makes it easy to miss one or two things. So thank you for bringing that out. That's something I usually try to point out. Any other questions? Okay, so carrying on. I didn't even need the coffee for that. That's cool. All right, so slides. Got it. So we'll go back here. Oh, yes, the coding. Play from current slide. I don't have a ton of slides, so even if it restarted, that wouldn't be the end of the world, but this is not, oh, yes, okay. All right, so that is all well and good. Here's kind of the 10,000 foot. Oh boy. Okay, so here's the 10,000 foot view of kind of what you're looking at when you have a microservices architecture using Spring Boot, Spring Cloud, right? So if you look at it kind of in the middle, this is where we live most of the time as developers. We build out portfolios of microservices. We have various different instances of each of them running perhaps in different locations, probably in different locations, right? They need some way to find each other. That's where the service registry comes in. You have a circuit breaker dashboard, which I didn't get into. That's a different animal as well, but that's something that we'll kind of talk about as we go. Config dashboard, distributed tracing. Then you look at your different cloud services that you typically have to interact with, or local services in my case for the demo so far, where you have message brokers, databases, etc. You have an API gateway which controls or channels access to all of these things. And then you have different app consumers on the front end. Regardless of what method they use to access your beautiful portfolio of microservices, they have to get there somehow. Seems like there was something I was going to mention before I went on with this, but I can't think of what it was, so I'll probably think of it later too. Okay, so when you look at taking things to the cloud, oh, I remembered what it was. Good, that was so quick. So as developers, we take on complexity many times not because we want to, but because we need to. And if you think back to what drew you into this field, what drew you to development in the first place, it's because we are typically problem solvers, right? We see a problem and we go, they should fix that. And pretty soon that they should fix that becomes, I should fix that, or I could fix that, or if they give me access to the source code, I'd fix that. Or maybe I'll just write my own solution. And then maybe you do that, and maybe you share that. But we get used to following this pattern, right? We see a problem, we fix it. And that's great. That's generally a pretty great thing. But what happens many times is that within an organization, there are blockers. And sometimes they're people, sometimes they're process, sometimes it's just a tool that holds up progress. And by progress, what I mean is delivering needed functionality to your customers, your end users, the people who need the stuff that you're building, right? So what typically happens when we hit those points, those blockers? In many cases, we try to work through the proper channels. We try to get things done the right way, the way it's always been done. But ultimately, what happens when the rubber meets the road is we say, just give me the ability to push it, and I will do that. Just give me the lever that I can pull, and I will make that happen. And that's good, right? We see a problem, we solve it. The problem with that is that each time after that, each time you've been given the ability to manually, to personally set your own settings for a service or a database or a messaging platform or a deployment pipeline, the next time you have to do something like that, it's all yours, right? You have ownership of that whole thing now. So you find yourself crafting YAML files and spinning up, images, creating images and defining certain orchestration rules and all the stuff that have nothing to do with the critical path, that have nothing to do with developing and deploying software that solves the needs of your users. Now, I mean, they're tangentially related, right? They have to happen in order to get that software out there in front of the people who need it. But it's not on the critical path. But we find ourselves doing it over and over and over again. And eventually what we realize is that in many cases, we're not doing not spending the majority of our time actually developing and delivering business critical, business value to our end users. We're actually doing all the stuff we need to do that. So I always like to say that we embrace complexity, not necessarily because we want to, but because it's out of necessity to get done what we know we need to do. When it comes to building microservices, there's some complexity there, but again, we get the job done. But then when we start putting these things into production, it gets a lot more complicated very quickly. So when we want to take this to the cloud, there have been many promises over the years on ways to do this and take some of the complexity out of our hands without taking power out of our hands, right? So anybody remember Platform as a Service, PaaS? I mean, they're still out there. They still work. They weren't a complete fulfillment of the promises, right? But then again, neither was the JVM. JVM is an awesome, awesome thing. But remember Write Once, Run Anywhere? Yeah, chuckles. I do too. I still look fondly on those, brilliantly naive days. But I mean, we have to start somewhere. And if you don't set the goal high, we never get anywhere close to that. And we are realizing some of that just in different ways than perhaps we ever imagined. So I guess it eventually works out. But if there was a way to get the power of Kubernetes, to utilize all the things that I showed you and not have to go through the painstaking handcrafting of all those things is in terms of not just building, but delivering, that's a good thing. So a number of years ago, Microsoft and Pivotal at the time came together and said, look, there should be some way that we can build all this stuff, deploy it, put it on top of Kubernetes, give developers the power they need, but not force them to hand define everything all the way through, which is kind of following that whole Spring ethos, right? Developer first, certain sensible defaults, optimize and allow you to override where auto configuration doesn't make sense, but auto configuration does a lot of work for you and takes care of things that you don't necessarily want to fix or change or tweak in 90+% of the cases. So that's kind of how this evolved. That's how this was created. Over time, Pivotal became VMware. VMware, we don't know what the next iteration is going to be with the acquisition, but we'll see. And that partnership looks like it's going to still obviously be needed because of the idea that developers want to have the power to do certain things that they might need to do, but in 90+% of the cases, they just want it to deploy and work, right? And that's where Azure Spring Apps comes into being, because everything that you see down here that we pretty much talked about is covered within Azure Spring Apps. And it's jointly supported by Microsoft and by VMware. So the Spring team is on it, our Azure team is on it. If there are any breakages that occur, any weirdness that happens, there's no finger pointing, there's no ball dropping, it's just covered, right? It's a collaborative effort. So all that stuff becomes this. There are multiple tiers, different cost structures. If you like any of them, great. use one. If you don't, again, there's nothing stopping you from deploying every one of these things manually and maintaining it yourself. Absolutely. It's costly in terms of time, so it may or may not make sense, but you have the options. You have the power in your hands. So making the cloud work for you. This is going to be a really short demo because I don't necessarily want to push the sales pitch, but I want to show you some of the things that a well-crafted platform can do for you if you want to take this to the cloud. So as Howard says, we need to believe. So let's go from there. And this, let me blow that up a bit. So this is the Build Better, Deploy Faster service that I've deployed in Azure Spring Apps. Everything I showed you, it's just covered here, right? I'm going to give you, like I said, a super quick overview because my purpose isn't to sell you on it. It's to show you an option you have available. Nobody else has this kind of prepackaged all-in-one solution, soup to nuts, fully supported by both vendors, but it can be done elsewhere. You can deploy all this. It just takes more work. So I'm going to start with, let's see, what do I want to start with? I guess let's start with the config server. So the config server is right here, and once again, just the same as we showed earlier. It points to a config repo, and you can define a particular label. So if you want a particular branch in your repo, it will point to that and use that, and you can change that out at will for different services. You can have, I have mine just set to public, but you can have yours set where it authenticates and actually pulls from private repos, which in production you typically would. But again, flexibility. If we look at the applications that are deployed here, so we can see that I have the airport service. And by the way, the discovery service, which is still based on Eureka out here, is kind of running behind the scenes. I don't have to configure that at all. It's just out there running, right? And config services as well. You point it to the repo, but then it handles all the rest based on your properties that you provide. So airport service, conditions, gateway, etc. So if I pull up the gateway service, and then you can see that we've got a URL. You've got test endpoints as well, but I'll just go into the URL here. Zoom back out so we can see it. And there's our liveness check. If I want to, we'll do the condition summary. That just kind of hits it all. Oh, that's ugly. Okay, hold on. So I don't have my pretty formatting there. I actually use Brave, as you've seen, for a lot of my stuff. Boom. So that's a little prettier, a little brighter too. So it works exactly the same way. It gives you a URL that, again, is tracked through the discovery service so everything can find everything. Gateway works the same way. It just strips off that prefix as the same rules. Again, once again, it's the exact same rules locally or there. Strips it off, passes through what I want passed through, and then retrieves the values from the other services using the same service name lookup, right? Let's see. So if I go back here, so there are apps. Let me go back. Config server is there, as I showed. You can define different alerts, metrics, diagnostics. You can plumb through your logs. You can set up your scaling rules. And by the way, the scaling rules are nested. So if you have a certain thing that you know that every evening from midnight to 4 a.m. the load is lower, you can have it automatically scale down. If you know that Black Friday is coming up and that's going to be an insane weekend for retail, and this is a retail application, you can set it from Thursday at 5 p.m. all the way through Monday at 7 a.m. or whatever the case may be, and you can have that scale. Those don't conflict, they just build, right? You can also have your, if for some reason things just go bananas outside of those, or even within that, you can have scaling based on your metrics, your CPU load, your throughput, things like that. You can go and check your application logs, config server logs. So you can dive into this as well. It also gives you a way to get application insights. Yes, I know, that's fine, delete that. Let's move on. Hit the application insights. And then if we go to my application map, it can give you a really good idea of, and that, which reminds me, that's one of the things that I did not show you on, this is why I really need a more granular checklist. So if I go back over here to my Zipkin, close, 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 Zipkin. So if I look at the dependencies here, and that was a little bit ago, so let's back that up to 44 and see if I get anything here. Ah, there we go. That's nice. So, and that does not give me what I wanted, what I hoped for. So I'll just zoom in manually. So it shows exactly what's happening here. Even in Zipkin, it'll show you kind of the, doesn't give you maybe as much granularity in Zipkin as you might like, but it'll actually show you the interactions between your services. This gives you that a little bit more. You can, which I need to expand this to last 4 hours, and you can see a bit more about the, so if you see that here we've got potentially slow calls that we can look into and diagnose perhaps something that's going wrong, and you can show this where it gives you a little better perspective as well. Anything else that I want to show you before I just kind of turn it over to Q&A? I think that's basically it. I mean, again, there are a lot of things. You can set alerts based on different metrics you might encounter. You can dig into performance and look at your dependencies and then drill into it that way as well. There's just a lot here, which is, I guess, good, right? Anyway, so that, I think, wraps it up, except for, coming back to my slides here. All right. So if you want to look at the code, work with the code yourself, by all means, it is out here. The config is separate. It needs to be a separate repository so config server can address it properly. So that's my build better config. Everything else, all the different services are out in the build better, deploy faster repo. The book, Twitter handle, and my Twitter handle, of course. That's all I have for right now. I just wanted to leave some time for Q&A. So at this point, anything that you had burning questions throughout or that you think of now? Stunned silence. Yes? I'm sorry, I missed. We struggled with the configuration, the authentication on the config server. Okay. Yes. What was the question about the? How to do it? I mean, interestingly, yes. I'm glad you brought that up because that was one thing that I did forget to mention, kind of piggybacking on that, then I want to return to your question. Because I use Java Cryptography Engine, JCE, well, the config server did. When you go to the cloud, Azure has a thing called Key Vault, which is truly passwordless. There's no encryption, decryption, there's no key. It's actually, well, there is, but once you do that, you just have to have an app token, a client token, to retrieve that information, so you never see it. It's never exposed per se. Whereas in this regard, it is exposed because your config server decrypts it and then provides that value. Now, if you're most of the time you're running this behind the firewall, so there's not necessarily as much risk of exfiltration of that. Or you can also have HTTPS, secure communications among your different services. But ultimately, the config service is decrypting that and then providing that as plain text, if you will, to different services. Now, what your question, I think, is I forgot to mention the whole Key Vault thing, and I apologize for that, because that's really a super important thing. Obviously, the more you deploy to cloud, the more secure you have to make your security posture, right? The way config service works, if you're running it locally like that, is if you have the cryptography files in your JDK, which since I think 8 have shipped with it by default. Before there were export restrictions and all this stuff where you had to actually download those files separately. But gosh, that's been years since you had to do that. And I think the Spring Cloud config server documentation still doesn't reflect that. I need to submit a PR because it still makes reference to that at least. But what happens if those files are present, which again on any default, any JDK install over the last several years they will be, it has a capability to encrypt or decrypt on command. So it will encrypt any key that you provide it with just by hitting the encrypt key endpoint. And then I throw in a couple of flags because it strips out all the extra stuff and reduces the noise and keeps it clean. But you can encrypt that, store it, and then anytime you access the config service, I have it externalized. You would typically, if you're running config service either locally or in the cloud, you'd have an encrypt key provided in some way, some manner. And then the config service will read that, say it has the encryption key that it needs to decrypt a value that it has that is stored encrypted with the brace cipher at the beginning of it. If it doesn't find that, it will just add that invalid to the key value or the key itself, the key name, and provide a not available value, NA. If it has that, it'll decrypt it and provide that up on request in the application. The example I used puts it in the application.yaml, which means every service anywhere can get to it, which is kind of an anti-pattern. I'll just be clear about that. But I did that because I have multiple services referencing that, and I was just being lazy for a demo. But typically what you do is provide that in specifically to those specific applications who identify themselves as a particular kind of service, and therefore it would just be decrypted for them. Does that make sense? Is that kind of where you were going with it, or did I miss entirely? Oh, I see. Okay. Config service, the running locally, there's not really authentication. It has to have access to it by default. So it's a, like I was running locally, that's fine. You can also run to a public repo if you're using it, GitLab, GitHub, whatever. In Azure Spring Apps, you can use authentication, which actually is providing a token via, well, I point to GitHub. So it provides a token there via GitHub, and then it will use that token. Well, again, I'm a bad example because I just have a public repo I'm pointing to, but personal access token. Let me see if I can go in here and show that, because that does allow you to keep it hidden from view. So yeah, can you? Nope. Hold on. Let me go back. I'm pulling this up and it's not showing that. There we go. All right. Sweet. All right, there we go. So if I click on this, and then let me zoom in here, so you can provide different authentication mechanisms to secure your Git repo. And that's through Azure Spring Apps, so that's not native to Spring Cloud Config Service. Sorry. But this does give you the ability to secure your repo, which you would definitely want, one way or another. Anyone else? Yes. Next.
So the gateway.
Yes.
Use the discovery service to find all the endpoints available?
Yes. The question was the gateway, does it use a discovery service to find all endpoints available? Yes. Affirmative. Okay. I thought you were building onto the next one. Yes, it does. Absolutely. Because I have gateway set up as a discovery client. I mean, you don't have to go that route, but it makes a lot of sense to continue down that path because that way it finds everything and routes automagically.
So if you want to do any configuration, then you have to run it first to get to gather all the endpoints that exist before you can say, oh yeah, process this URL somehow, remove this many joins from the URL before passing on the request. If you want to do any configuration like that, you have to first run it then, so that it can discover all the endpoints.
Okay, so the short answer is no, because there's nothing that requires you to use the discovery service. But the long answer is, if you want to use the discovery service for all that, yes. But either way. So let's do a scenario. So if we're using the discovery service, as I showed, so we're saying via the gateway, we want to access the condition service, and then we want to strip off that last strip off the one prefix for condition service, right? And then just go from there, past whatever's after that to the condition service. So in my case, from the gateway, I was like, I asked for condition service / summary. And then it has to know where that's located. But either way, even if it uses discovery service or not, it's going to strip anything that's preceding that. So if I point it to condition service, whatever, or if I point it to an IP address and whatever, it'll strip that first chunk of whatever off. So then after that, it's just /summary, and it passes that to wherever I told it to pass. So at that point, you're still just passing on that /summary. Does that make sense, or did I just make things worse?
No, I get how that configuration works, but you first need to know about all the endpoints before configuring the different endpoints.
Yes.
So
No, because the way I did it, I guess we'll start there. Because the way I did it is I had it be a gateway, or excuse me, a discovery service client, so it will store that in memory. The reason I was giving you the other answer is that sometimes you'll see, like Spencer will do a demo where he points to an external API. I can't remember what it is, but it's just an endpoint that people test against, and that is hard coded in, but it works exactly the same way. The difference is that as a discovery service client, it will cache that in memory. So then it has that reference, and it does, yeah, it strips the first part off based on what it has for the location you're trying to reach. Yes?
Is this solution, this Azure solution based on Kubernetes?
Yes. Oh, I really should get better at what I'm showing on this stuff because I get really excited about the code, and the other stuff it's very important. I don't want to say it's not, but it's less fun to cover maybe. Oh sure, start all over. Why not? Good thing I don't have a whole lot of slides. So yeah, if you look down at the bottom, it's all based on the Azure Kubernetes service. So everything runs on Kubernetes, and that gives you, you do still have access via the Azure APIs to get out and tweak things. You can spin up external Azure services and access them from Azure Spring Apps, from your applications deployed in Azure Spring Apps. So you get the full access to the platform. It's kind of like the Spring Auto configuration, Spring Boot's auto configuration. You don't have to tweak a lot of these things unless you want to, but it doesn't really stop you from doing any of that and accessing all of that. So it's all based on AKS because as much as anybody might have had a stake in Cloud Foundry or anything like that, Kubernetes is pretty much where the world runs now. So it gives you the power of Kubernetes without having to handcraft bespoke YAML files. Yes? Oh, sure. Mm-hmm. Yes, you can implement server-side load balancing, but generally speaking, the default is just client-side load balancing based on the values that's provided by the discovery service to any discovery client. And it's just a simple round-robin algorithm. When it was using Ribbon, there was an override. I don't know that there is by default now. Again, we're going to be talking actually about some of the like the node sidecar and things. Ping me on that as well, and I'll find out on that because I've not seen the ability to do that with the current constructs, but I don't know that it's impossible. I just know that by default it is round robin. Yes. Oh, sorry.
When running my Spring Boot application on a raw Kubernetes cluster, maybe in a Docker container, is there any point in using the service discovery provided by Eureka? Because Kubernetes has its own service thingy. Are there any gains in using Eureka additionally on top, or is it just super fused then?
I think a lot of it. If you have an existing large installation of Spring Boot applications running natively on Kubernetes, I don't know that you're going to necessarily want to re-implement certain aspects of that. If you have certain Spring Cloud portfolios you're running, or you're looking at a way to deploy things in a way that is a little more, that does a little more work for you, then I think it makes a lot of sense. I'm not sure if you've got some of those things in place already that it makes sense to implement the discovery service on top of. I've got mixed feelings about all of that. I mean, Kubernetes is developing far more as an ecosystem in terms of some of the scaffolding it provides and services provide for it. But if you're already at least well versed in this, I think it makes sense to implement it. If you're already neck deep in the other, then perhaps not. I guess I hate to use the old "it depends" because that always drives me crazy, but. Your circumstances are probably going to dictate that decision more than you and I can. Sure. Okay, if anybody has any questions, we've got a little bit of time left. I'll be here, So come up and see me afterward. I'd be happy to chat. And if you have questions afterward, ping me on Twitter or email. I'd be happy to find out more about that as well. But thank you very much for your time. Go DevOps.